Okay, so let's talk now about odds ratio. The difference between odds ratio and risk ratio is really subtle, and often you'll see them written interchangeably. They shouldn't be written interchangeably. They are two different things, and you'll see when we calculate it that there are two different calculations that go along with it. But for some reason, a lot of people are kind of confused about it. I guess one of the reasons why it's been interchangeable a little bit, or people get a little bit lost with it, is because if one of the outcomes in the groups is close to 0, or if there's very few numbers in some of the groups, then the outcome can be really similar. But as numbers get bigger, then the outcomes tend to differ. So which one do people use, odds ratio or risk ratio? The more common one to use is risk ratio. But there are times when we can't use risk ratio, and so then we go to odds ratio. Now, risk ratio is something that we know, right? We know the risk of something happening. We know the numbers that are there. We know the probability of something happening sometimes. Other times we don't necessarily, and we need to go into odds ratio. Or other times when something is close to 0, sometimes an odd ratio can give you a more accurate information. The recommendation is to use risk ratio where you can, and to only use odds ratio in times when the risk ratio doesn't fit. So let's have a look at how to calculate it. You can see we've got the same box. Yeah, it's the same box here when we're talking about exposure or what did I use, variable present in the last one. That's the same information here, and then outcome is the same one here. Now this is a calculation looking at chance of getting cancer. Let's just assume that we're talking about exposure to secondhand smoke and the chance of getting cancer here, right? So we've got exposure yes on the top line, exposure no. So exposure to secondhand smoke, yes, I worked in an office where people smoked, or no, I didn't work in an office where people smoked, and yes, I got cancer down here, and no, I didn't get cancer down this one. Okay, and then here is the calculation here. It's slightly different. In a way, it's quite similar in terms of how it's calculated. A divided by B, that would be in brackets, so we'd do that calculation first and divide that whole thing by C divided by D, which we would have calculated before we divide the two of them. Now the way that division and fractions work is that you can swap the last two around, right, and you can multiply them, which gives you this ADBC calculation here. But if you want to, you can just ignore that and go ahead and calculate it like this. Whichever way you're feeling comfortable with. If you're comfortable with the idea about reversing fractions and multiplying, then you can go straight ahead and use this. This is A multiplied by D divided by B multiplied by C. Or you can just go ahead and do this. It will give you the same answer, so it doesn't matter. So what they've done here is they've filled in an example. We've got A. Okay, so let's have a look at this example here. They haven't used this one here. They've gone A divided by B, A divided by B, and they're dividing it C divided by D, C divided by D, and then they've calculated it all out. So let's go ahead and do one here. I've just written the box up here. This is the same box we used before when we were looking at risk ratio, variable present, variable not present, outcome yes, outcome no, and I've just labeled the boxes A, B, C, D. So let's say I tried again to invent another birth control method, and this time I got some different results, but we still know the same results from last time, right? Variable not present. So let's go ahead and fill them in. Variable not present was if we don't have the birth control, 3 and 7 people who didn't get pregnant. Okay, and then I've updated it and modernized it, and now 1 person got pregnant on my birth control and 19 didn't get pregnant on my birth control, right? And you can see when we go back and we look at odds, the same difference between looking at risk and odds when we're not talking about ratios is that risk is looking at the chance of something happening divided by the whole population, and odds is the chance of something happening divided by the chance of it not happening, right? So one is looking at the whole population and one is just looking at it not happening. So the difference is here when we're doing the second calculation, we're not adding A and B together here. We're just looking at the chance of it happening divided by the chance of it not happening. So let's go back to our whiteboard. Let's do that first one, top one first. We're looking for the chance of something happening. I'll do it down here. The chance of something happening divided by the chance of it not happening is 19. We don't add those two together anymore. We're going to divide that answer by the chance of something happening, by the probability, by the positive outcome, so the positive pregnancy test with the variable not present, dividing by the negative outcomes from the variable not present. Yeah. So we're just doing A, B, C, D again, but we're not adding A and B together. So this is exactly the same. I'm not going to be able to do this without my calculator because I know that I'm not that good at math. 1 divided by 19. So the answer to this first one is going to be, whoops, where'd my calculator go? Come back, calculator. Was 0.052. I'm just going to go to 2 decimal places. Oh, there should be a 3 then. Yep, I'm going to 2 decimal places. I'll just overwrite that. 0.053 divided by 3 divided by 7. Again, I can't do that in my head. 3 divided, that's multiplied by, divided by 7 is 0.4, what am I doing, 3 decimal places? 0.429 divided by 0.429. Okay, and we're going to give that again. I'm not going to be able to do that in my head. So 0.053 divided by 0.429 gives us an odds ratio of 1 to 3. 1 to 4 actually, isn't it? If we're going to do 3 decimal places, 1 to 4. Because it's an answer, I have to make it 3 decimal places. I have to let it know that 3 decimal places. So this is the odds ratio. And again, closest to 1. If your odds ratio is 1, it means there's no difference. So you can see here that this is quite a long way from 1. So 0.124 means that actually I did it this time, and now I'm going to give up being a midwife and I'm going to sell my birth control and make lots of money, because the odds of getting pregnant on this birth control is very low compared to the odds of getting pregnant with using nothing. Obviously 1 in 19 to me is still pretty big, and I'd like to find a more effective form of birth control, but if we're comparing it to not using any birth control as opposed to using a birth control method that's already out there, then it works really well. What we would then need to do, right, is go ahead and compare it to using the pill or using some other form of birth control method, and that would come up with another whole new set of odds, which might mean that I'm not going to come rich and famous making birth control after all, and I should really stick with being a midwife. Okay, I hope that helps. Don't forget, you can go back and watch these if you need to, and also you can attend the online class, or you can contact me. Please, if you have questions, don't hesitate to contact me, and we can help. I can help. All right, hope this helps.